Construction of Geiger-Muller counter. It consists of a hollow metal case enclosed in a thin glass tube. This hollow metal case acts as a cathode. A fine tungsten wire is stretched along the axis of the tube and is insulated by ebonite plugs. This fine tungsten wire acts as anode. The tube is evacuated and then partially filled with a mixture of 90% argon at 10 cm pressure and 10% ethyl alcohol vapors at 1 cm pressure. Sten. The fine tungsten wire is connected to positive terminal of a high-tension battery through a resistance R and the negative terminal is connected to the metal tube. The direct current voltage is kept slightly less than that, which will cause a discharge between the electrodes. At one end of the tube a thin window of mica is arranged to allow the entry of radiation into the tube. Principle of Geiger-Muller counter. The basic principle of the Geiger-Muller counter can be understood as follows. When an ionizing particle passes through the gas in an ionizing chamber, it produces a few ions. If the applied potential difference is strong enough, these ions will produce a secondary ion avalanche whose total effect will be proportional to the energy associated with the primary ionizing event. If the applied potential difference is very high, the secondary ionization phenomenon becomes so dominant that the primary ionizing event loses its importance. In other words, the size of the final pulse produced depends only on the triggering off of ionization by an ionizing particle but independent of the energy of this particle. A high-energy particle entering through the mica window will cause one or more of the argon atoms to ionize. The electrons and ions of argon thus produced cause other argon atoms to ionize in a cascade effect. The result of this one event is sudden, massive electrical discharge that causes a current pulse. The current through R produces a voltage pulse of the order of 10 microvolts. An electron pulse amplifier accepts the small pulse voltage and amplifies them to about 5 to 50 V. The amplified output is then applied to a counter. As each incoming particle produces a pulse, the number of incoming particles can be counted. Working of Geiger-Muller counter. The tube is filled with argon gas, and a round voltage of plus 400 volts is applied to the thin wire in the middle. When a particle arrives into the tube, it takes an electron from argon atom. The electron is attracted to the central wire, and as it rushes towards the wire, the electron will knock other electrons from argon atoms, causing an avalanche. Thus one single incoming particle will cause many electrons to arrive at the wire, creating a pulse which can be amplified and counted. This gives us a very sensitive detector. The principle of working of GM counter. The ionizing particle passing through the tube ionizes the gas and electrons so produced move towards anode. The velocity is quite high and they later produce secondary electrons after repeated collisions with the particles of the gas. These secondary electrons further produce more electrons in geometric progression. Due to this large multiplication action, a large ionization current is produced. Advantages of GM counter. It can count alpha, beta, gamma particles as well as cosmic rays. It has high sensitivity. Power supply need not be precisely regulated as the pulse height is constant over a large range, because of the fact that output pulse is very high, so the amplification needed is also very subtle.